So first, I'm glad I have the chance to join the conference. This was a decision made like 2 weeks back. And it's a great chance to come here to talk social with people from different industry and listen to all the presentation to get some idea for the future work. So let's see. So in this presentation, I'm going to quickly give you an overview of our organization, go through the problem statement, the goal and objective of this simulation, and any large model, show you the any large model, and then a quick summary. Okay. So just like just mentioned, our team is called SCIA, nothing to do with the CIA, but we are supply chain intelligence and analytics team. So basically, our mission is just we are a consultant team within our parent organization. So anything they have the problem, they need help, they come to us, and we provide service to them. And we are a small team of 12 people. We have operation research engineer, we have software engineer, data scientists, and statisticians. Okay, so like the previous presenter, my background is software. Doing simulation model is kind of by chance for me. I joined the team about 3 years back, and basically my manager stopped by and asked me if I'm interested in doing some simulation work. We have a couple of models developed by previous employer. They all left, so he needs somebody to go understand what's been done. And that's when I start doing the simulation. About 2 years back, my manager and other folks go attend a conference. That's when they find out Anylogic. They bring me back and say, hey, go try it and see if this is helpful. I tried it. I like it personally. With the software engineer background, I like the Java feature. Very easy to maintain and object-oriented approach. And so since then, I think I never go back to the other simulation software. Okay. So just a problem statement here. I think this is about a year ago. Our equipment commodity manager and the equipment engineer are dealing with some problem at a factory. What happened is there's this particular part in the equipment. It breaks from time to time and causes the capacity constraint in the factory. And this part is not for one-time use. You break, you just throw it away, replace a new one. This part is actually fixable. They can be fixed locally by a technician inside Intel factory, or if the problem is too big, they have to ship back to the supplier to be fixed in their repair center. The commodity manager and the vendor, they are working closely together to fix the problem, but they don't seem to able to agree on what is the root cause and what the solution should be. So the commodity manager approached us and said, this is an urgent request. We have a meeting with the supplier next week. Can you just create some model and provide us some data to help us to negotiate with the supplier? So that's where we get involved in this situation. Just some more background about this whole situation. One important factor is this part on the equipment is actually expensive. And the tool itself is the capacity constraint. So we really don't want to have the downtime, otherwise it will cause the production issue. And they also found out the failure rate of these particular parts very depends on the product being run through the machine. And they also found out that usually during the new product ramp, the failure rate was slightly higher before it's stable. Okay. And like I say, the product can be fixed locally, or they have to they require to ship back to the vendor for repair. And if this part has to ship back to the vendor, because the Intel factory and the repair center, suppliers repair center are located on the different country, so the entire cycle time is very long, significantly longer than fixed in the local. Okay, and finally, interesting thing is that this situation only happen on certain sites. There are other sites that are running fine. So it's kind of curious, for those sites that are running okay, are they just managing their inventory, the spare part inventory very well, or actually they're just ordering a lot more spare just to prevent this issue from happening? Okay. So next, the commodity manager kind of shows us the graph. Oh, this is the flow of what a failure part will go through. So as you can see here, when the part failed, there's a decision make, basically decide if they can fix locally and then return to the inventory as a usable part, or they have to ship back to the supplier. Then it has to go through some paperwork, go through the international shipping, then go back to the vendor. They have a custom broker, which is deal with all the custom, then fix at the repair center, and then ship it back. Okay. So after we listen to their problem and immediately come to and look at this repair loop, we kind of think that this is really a problem fit very well to solve using the simulation. If we can get all the information we need, like the failure rate, how often it fails, the time at each process step, and percentage, how a percentage of the part can be fixed locally and also at a repair center, vendor's repair center, then we can run a simulation and kind of show the current situation. Right. So once we understand the problem, we define a goal here. So with the commodity measure, basically we want to know that how many spare parts we have to purchase to avoid the equipment downtime, and also we don't want to overbuy these spares because the part is very expensive. And they also want to know that, well, what if we can improve the failure rate? What does it impact the overall available parts? And the other things we want to look at it is how about let's change it, increase some staffing in basically the resource at local and the vendor's repair center to see if we can improve the situation by just increase the resource that can put on to fix those parts. And the final one is support the vendor negotiation. Basically, the commodity manager is looking for us to provide some data that can support the negotiation, and it would be better that they can kind of show this model to the supplier and tell them this is what we got, this is how we derive the inventory we need. So anyway, so Anylogic basically fit this thing very well, right? You can send it. One of the big advantages of Anylogic is you can export your model into an executable. You send it to anyone, they can run and just test at whatever they want. Okay. So next, I'm going to show you simulation model. Well, this is a very simple model here. And if you look at it, this is exactly simulate the repair loop I just showed before. And from part fail, if part fail, you decide it has to be fixed locally or you have to go to the vendor's repair center. And you may be wondering why there's two loops over there. So again, this is kind of learning I got at that time when we haven't have all the detailed information about those parameters. I just assumed that everything should be the same, but it turned out to we have a certain site, it has a longer TPT. So I have kind of has to make a different loop for that. And also, originally, when I started simulation, we are looking at the whole factory network, but the commodity manager really want to see, zoom in the problem into a particular site. So what we have is one loop here simulate the site we are interested, and the other loop basically is the aggregate information for all other sites. And again, very simple model, and it looks like just someone is following the tutorial, try to create their first simulation model. And this is a user interface. So in the real simulation, I have all the parameter filled in by the default, which is the current situation, about how many parts we have right now, what is the failure rate at the site, what is the TPT, how many resources they have, and they can run the simulation. And so basically here we run a 1 year long simulation, and each line here represents the available parts we can use for over 1 year of time. So I set up this simulation as you can do it a comparable run, which you can change the parameter, and basically each simulation will show you the different configuration. Or you can set it run as a Monte Carlo simulation. Basically, you run it, you can run the same simulation or same set of parameters multiple times, and it shows you all the each run information. And so if you look at here, if you have this line here is the minimum part you need to keep your equipment running. Then when there's a dip, which means that there's a potential time that you will be short of the part. And when we show this to the commodity manager, he's really excited about it because they can play around and just see where they can actually run the simulation, tweak the parameter, and see if we have enough part or not. And really, I haven't done anything more like any data analysis to calculate all the possibility, everything. Nothing there yet. Once they see this graph, they're excited and see, okay, this is what we want. We can use this, right? So just a quick summary. This simulation actually took only a few days to complete after we spoke to the user and identify all the requirements, get all the data to do the simulation. Actually, the commodity manager was able to show the simulation during the meeting when they meet with the supplier and show them the data. This is what we saw the problem is, and we think we need this extra part to keep our factory running smoothly. And they are able to use the data to convince the supplier, and they agree to provide some consignment for us. Basically, it's free for us to use in emergency case if we don't have another part in our factory, and which is a significant saving to Intel. And the simulation model is very to understand. It's very easy to use as standalone application. So basically, we have this engineer, the equipment engineer say, hey, this is useful for us too. We can use that to analyze and predict the failure rate impact to the available inventory and see if we need to have some additional buffer and basically see that the failure rate change impact to the overall situation. And from what I learned is that this simulation can also to modify to fit to model other spare parts similar to model similar problem. And so I think for a few days of work and get some return, I think the ROI is pretty good. Although the saving is not at hundreds of millions, but for 2 days of my work and to produce some significant, some saving for Intel, I think this is interesting. This is an interesting project for me to do. Just some final thoughts that it is a very simple simulation, like I say, but just kind of surprising. Nobody did it before for the commodity manager, for them to understand the problem. And is this the perfect model? I would say no, because if I have more time, I will probably make it better. But since they are done negotiation, they don't need it anymore. So basically, but that's a kind of learning. Next time, I know that what I can improve. One other thing is no small problem is too small for simulation. Anytime you can use it, I think it's great. So this is my presentation. Thank you.